This is a B4 bioenergetics video looking at photosynthesis, and we're looking at rate of photosynthesis. Now this is a higher only video, okay? For higher, we need to be able to analyse a graph with more than one limiting factor. Now this is quite tricky. I can make some general statements here, okay? I can say, if I just look at carbon dioxide, at 0.03% of carbon dioxide, there is a lower rate of reaction than at 4% carbon dioxide. I can see that straight away. So that's one conclusion. I can say that at 25 degrees, there is a higher rate of photosynthesis than at 15 degrees. I see it in both concentrations of carbon dioxide. Higher rate of photosynthesis at 25 degrees C than at 15 degrees C. So I can talk about temperature. I could also talk about light intensity, because as light intensity goes up, so does the rate of photosynthesis. Now, where it becomes quite challenging, if I look at the bottom two lines and I look at light intensity gets to its optimum and stops being a limiting factor at very low light intensities when using a low concentration of carbon dioxide. If I use a higher concentration of carbon dioxide, I can see that light intensity reaches its optimum at a much higher light intensity. Okay, so it could be that we did the light intensity at low concentrations of carbon dioxide and we found the optimum to be around about here. Then the next thing we could have investigated could have been the concentration of carbon dioxide, and we find that it obviously has an impact, but if we use the same light intensity that we'd already found down here, we'd find our optimum to be around about here. So we have to then go back at our higher concentration of carbon dioxide and try light intensity again, and it shifts the optimum all the way over. So it's about retesting and retesting all the different variables so you can get kind of the ultimate optimum conditions. So if I was to say a conclusion here, I would say the optimum conditions are a light intensity around about 2/3, 4% carbon dioxide and 25 degrees C. Hopefully that makes sense. Again, another higher concept, inverse square law. Okay, this is about working out how far away the lamp affects the intensity of the light. Now, I've put the grid on there to help us with our squaring of numbers, okay? If a lamp is moved twice as far away, the light intensity decreases by 4 times. Now, twice as far, so I square 2, which gives me 4. So if I move it twice as far away, it's 4 times less bright. Okay, if the lamp is moved 3 times as far away, 3 3s, 9. Okay, the light intensity decreases by 9 times. And then the question says, if the lamp is moved 6 times as far away, how much will the light intensity decrease? 6 squared is 36. So if you move the lamp 6 times as far away, it will decrease its light intensity by 36 times. Now, this is the calculation that we tend to see in the exam. Light intensity is proportional to 1 over the distance squared. Let's look at an example. E.g., light intensity when light is 10 centimetres away, so 1 over 10 squared. Okay, 10 squared is 100, so 1 over that is 0.01 arbitrary units. Now, arbitrary units is something that we don't really talk about enough, I don't think. And it's, if I said to you, how happy are you on a scale of 1 to 10? Hopefully you'd say 10. That doesn't really have a unit to it. It's not, I'm not 10 meters happy, I'm not 10 seconds happy, I'm not 10 grams happy, okay? Because there is no unit to it, we call it an arbitrary unit. It's kind of a comparable unit, okay? So, if the light intensity is, the light is moved 20 centimeters away, then 1 over 20 squared is 0.0025 arbitrary units. Okay, much, much, much smaller than if you move it only 10 centimetres away. Hopefully that makes sense. Hope you found that useful. Thank you.